Good morning children. Welcome back once again to my maths class. Here today we are going to deal about sets. Okay. Now maths is not about numbers and calculations in our daily life. It's lot more than that. Every day, knowingly or unknowingly, we come across so many activities which unknowingly we will be dealing with them. So today the topic which we are going to deal is somewhat linked to our daily activities. Okay. Now let's get started with the topic. Today's topic is chapter 2 of our chapter 2 of sets, that is 10th class chapter 2 sets. Okay. Now children, if I tell you that you are all coming under you're all coming under one set. Okay. That means those who are all watching my video now are coming under one set. Then can you tell me what set it is? It's simply you are all watching this video coming under a set because you are the 10th class students of the batch. 10 students of the batch academic year 2020 and 21. So if I say that you are all who are watching this video come under a set, that means you are having some property in common, that is you are all 10 students of this academic year. Okay. Now if I tell that if you are all those who are not watching this video form a batch or form a collection, then those are the students, other students or other people, they form a collection. Here the collection is, in this collection you have the common property that you are all 10 students of this present year. Now I'll give you a few more examples of collections here. Let me take example. I'll write Gauss, Euclid, okay, Pythagoras, okay, then Aryabhatta, you can also write Leibniz, so many. This is one collection, I'll suppose. Okay, let me take another collection. Example 2. Simple A, E, I, O and U. Another 1, 3, 5, 7, 9 and so on. Okay. So these three I've given you for example. They are the collection of some ideas or objects or things. So in these three, see here, in these three you can observe that here I have written Gauss, Euclid, Pythagoras. They are the great mathematicians. Few of the great mathematicians I have listed out in a collection. Okay. And here they are the vowels of the alphabet, English alphabet, A, E, I, O, U. And here I have written 1, 3, 5, 7. They are the odd numbers. Okay. So this collection, if I represent in the form of flowery brackets, so I represent this few great mathematicians under a flowery bracket. Okay. And here I have listed out the vowels. Here the odd numbers. So they form a set. Like this is a set of, like if I mention it with a capital, I'll mention it with capital M. M set is having the great mathematicians, few of the great mathematicians. Here if I say V set is having, possessing the vowels, and if I say O, this is odd numbers, the set of odd numbers. That means a set is a well-defined collection of objects or things or ideas having a common property. Here the common property is that they are the mathematicians, here they are the vowels, here they are the odd numbers. So in all of them they are having a common property. So what is a set? A set is well-defined collection. It's a collection collection of objects, things or ideas, of objects or ideas. Here if I tell objects, all will come under that. The names, places, anything, okay? Or ideas having a common property. Having a common property. This is simply a set. Okay. Now I'll tell you few more examples I'll list out. If you take an example of let me take few examples of natural numbers. Capital N, 1, 2, 3, numbers starting with 1 and so on. So all these in our daily activities before classes also we were using the sets. Okay, so natural numbers, whole numbers and all these. So here the set is represented with curly brackets known as braces. Okay, these curly brackets or the flower brackets which we write here to represent the set, those are known as the braces. Okay, and these are the elements. Here the mathematician name is the element of the set M. Okay, and here the elements are A, E, I, O, U. The elements are separated by commas and they were placed in the curly brackets, and these sets are represented only with the uppercase letters, that is the capital letters M, V, A, all that, with only the capital letters. Okay, they are denoted with capital letters. These are called as the elements. The element phi is present in the set O, which are the set of odd numbers. Okay, here I'll list out some more examples for you. Like W. W is a set which we have already studied. That is, it starts from 1, 0, 1, 2, 3 and so on. Now if I say, if I give you another example like Z. It is a set of integers starting with minus infinity, minus 2, minus 1, 0, 1, 2, continue to infinity. Okay, these are all sets. They are represented in the braces and they are separated with the commas. These are called the elements. Now if I tell here, see here, A belongs to, small a belongs to the set V. That means element A is present in our set V, set of vowels. Okay, so this is called as belongs to. Belongs to. An element, if it is contained in that set, it is called as belongs to. This is a sign of belongs to. And if I take another one, if I take B, B does not belong to the set V. So B is a consonant, it does not belong to the set A. So this representation is does not belong to. Does not belong to. Okay. And likewise you can say another one here. If you take a even number 2. So element 2 does not belong to the set O. So that is all about belongs to and does not belong to. Now let's see, we know natural numbers, whole numbers, integers. I have listed out their sets. Okay. Now, if you're also we learned about the rational numbers. Can I represent the rational numbers? All the rational numbers. Can I list them out? No. But I can give the condition. What are the rational numbers? They can be formed in the form of P by Q, where P, Q are integers. Now, we know that how to represent belongs to. PQ belongs to the set Z. Earlier we studied PQ belongs to, they are integers. Now we can denote it with the mathematical sign Z, and whereas Q not equal to 0. So here rational numbers, I'm giving a condition. This is a condition of the rational numbers, but I'm not listing out the rational numbers because there are innumerable rational numbers. We cannot list them out. And also in between two integers we have number of rational numbers. So here, if you observe these three sets, natural numbers, whole numbers, integers, we could see a pattern here. I have listed out the elements. Here in this rational numbers, I haven't listed out, but I have written a condition of the rational numbers for which each and every element satisfies. So this type of representation of sets is called as the roster form. Okay children, clear? This sort of listing out the elements directly in the form of a set is called as the roster form. Whereas in the case of rational numbers, I haven't listed out, but I have given a condition where each and every element in this set possess this condition. So like this representation, it is called as the set builder form. Okay, it is called the set builder form of representation. The set building means we are giving a condition, we are building the set. We are not directly writing the list of elements here. Now, here these two forms are very important. Here, the roster form and the set builder form. Few more examples I'll give you. If I tell the same example vowels we take, I'll tell that this is a set of vowels. When I tell they are A, E, I, O, U. So this simply representation of the element is, elements are of the form of roster form. I want to convert this into the set builder form. Now let me write the set builder form for this. Here X such that these two colons, we call it as such that X such that X is a vowel in English alphabet. Okay. So this is a condition where we write in the set builder form like this. X such that X is a vowel in English alphabet. So the roster form of this is directly listing out the elements. Now for this also we can write for the N. Here it is in the roster form. Now I'll write it in the set builder form. Okay. X such that X is a natural number, or you can write X belongs to capital N, natural number. Okay. And natural number, if I stop this set till 5 or 6, suppose if I stop it here, if I am not giving it to infinity till 6, you can write the condition X is less than or equal to 6 here. Or else if it is continued till infinity, you can write X is a natural number, that's all, you can stop it. That means I have built this set in the form of a set builder form. X is a natural number, X is less than or equal to 6. Or simply here you can write X is less than 7. So the elements are below 7. So X is less than 7 or less than or equal to 6. Anyway you can write. Okay. This is the set builder form and the roster form. Whereas here also you can write for also Z, you can write for all. Q also we can write. Q also we can list it out like all the numbers in the form 3 by 2, 1 by 2, all you can write. They come under Q. But because that set is quite big, you can represent it in the set builder form. These are the two representations, roster form and set builder form. Now let's see few conversions. Here we learn about the conversions, converting roster form to the set builder form and set builder form to the roster form. This type of questions will be given for 2 marks in your examination. Okay. Now I have written 2 problems. One is in the set builder form, one is in the roster form. So the set builder form, we will change it into the roster form. Here X, A is a set X such that X is a 2-digit natural number and their sum of digits is 8. Okay. It is containing 2 digits natural numbers. This whole set is containing 2 digits natural numbers. That means from 10 to 99. Those are all 2 digits natural numbers. But there is another condition that their sum of digits is 8. Okay, the sum of the digits. Let us take here the tens place and the units place. Okay, the sum of the 2 digit number should be 8. If I start with 1, 7, the sum is 8, isn't it? 2, 6, 3, 5. Okay, these are all 2 digits number whose sum of the digits is 8. 4, 4, again 5, 5 plus 3, 8, 6 plus 2, 8, 7 plus 1, 8, 8 plus 0 also 8, because here they should be equal to 8. Okay, and also if I take 0 plus 8, 0 plus 8 also 8, but here 0 plus 8 comes to 8, but this will become a single digit number. Okay, it is 8, so we should not take this. Okay, till here these are all the 2 digits number whose sum is 8. Now we list out 17, 26, 35, 44, 53, 62, 71 and 80. So this is the roster form of the set A. Now coming to this problem, here directly list of elements is given. That means a roster form is given. We have to write in the form of set builder form. So let's write. So if you see there is a common property, first we have to see the common property here. That they are the multiples of 5. Yes, x such that x is a multiple of 5. Multiple of 5. And also the condition that multiples of 5 are infinite, 30, 31, but they have been stopped at 25. So that condition also we should have, such that x is less than 20, less than or equal to 25. Or you can simply say that less than 26, less than or equal to 25. So this condition is satisfied for each and every element of the set B. So these are conversion of the set builder to roster form and roster form to the set builder form. Now we'll go to another topic, that is null set. Okay, null set. Null set is a set having no elements in the set. Okay, now if I take a set builder form, if I take n, if I take A, x such that x is an odd number, x is an odd number divisible by 2. Okay, this is a set builder form, that is set A. So I'll write the roster form so that I'll get the elements. X is an odd number divisible by 2. Odd numbers are 1, 3, 5, 7 and so on. Are they divisible by 2? No. No odd number are exactly divisible by 2. If they are divided by 2, you get a remainder 1. But divisible by 2 means the remainder should be 0. So there are no elements in this set actually. So this is called as a null set. Here it is called as a null set or empty set, or also called as empty set, because there are no elements in this set. Empty set. It is represented by 5. We call this symbol as 5. 5, empty set, or also void set. Null set, empty set, void set. It is represented like this without elements. Also children, here null set is not equal to this set. Here in this null set we don't have any elements. Here in this set we have an element 0. So this is a set containing element 0. Those are not equal. Null set means simply there are no elements in it. Now let's proceed to the other. Quickly copy down, pause the video and copy down. Using diagrams to represent sets. Okay, the sets in the form of braces we have represented till now. Also we represented sets in roster form as well as the set builder form. Now, using the diagrams, we represent the set. Let me take an example of a set A. That will be equal to 2, 3, 5, 7. Okay. So, how do we represent this set diagrammatically? Like, they are represented in the oval shape. Okay. Now, I'll tell this set as A, and the elements here I write it 2, 3, 5 and 7. That means 2 element belongs to the set A. It is present in set. Also, like 7 belongs to A. And if I take 1 does not belong to A. And if I take 4 does not belong to A. Okay, 8 does not belong to A. So these elements, where do I write? Outside the set, like 1 here, 4, A. We write it outside the set. Only the elements present in the set A I have represented in a circular form in the oval shape. Okay. And let me take another example. Example 2 here. So if I tell that your school is a set. So I'll represent your school in the form of a rectangle. This is your school. Okay. So this set will represent it when you represent a bigger set, it is called as a universal set. Okay. Universal set, the school itself, we denote it with the U. The stroke is, you write the U, the stroke is a bit dragged. Okay, this is U, that is called a universal set. Okay, if I tell your school is a universal set, you have classrooms, you have staff room, you have the office room. Okay, I'll represent this as classrooms. Okay. About staff rooms here, the playground, okay, the office room, playground, the office room, classroom and the staff room. So all these rooms come under completing school. So this complete thing we represented with the total, we represented with the universal set in rectangles. Okay, the representation of the diagrams of the sets I am telling you. Okay, and for this also we represent the sets in the form of, here I told universal set, in the form of oval shaped where they are overlapping. If I tell A and B are two sets in the universal set mu, then they are, you represented them as overlapping. Why? I'll tell you. This sort of representation are called as Venn diagrams. Okay, or Venn Euler diagrams. We simply call them as Venn diagrams. Okay, oval shaped sets inside a, which are overlapping inside a rectangular box, which is the complete set, universal set. Okay, like if I tell the same thing 2, 3, 5, 7 or if I give some other names 8, 9, 10. Okay, so I'll represent here 2, 3, 5, 7, a set of A and 8, 9, 10. So this is a diagrammatic representation called as Venn diagrams. Let's proceed to the next one. Quickly pause the video and note down subsets. Okay, we know a set. Now we see the subsets. Okay, if I take an example A, 1, 2, 3, represented, differentiated by commas, represented in braces and a capital letter, denoted by capital letter. So this is a set. I'll write down the subset. If I say set 1, 2, 3, or 1, 2, 2, 3, okay, 3, 1, also the set 1, 2, 3, okay. These are all the subsets of the set. That means a part of the set is nothing but the subset, part of the main set. The part of the set, like I see here, one element I've written, this is a set. this set, if I represent it with B, this is with C. So B is a subset of A. That means the part of a set present in the main set. So 2 is a part of the set here. 3, 1 and 2 is a part of the set, isn't it? So if I take this as E, E is 1, 2. So E is a subset. So in some textbooks you have the representation like this, or else just you can represent here C is a subset of A, because C is 2, it is contained in A. This is a part of the set, main set. So you can write an elongated E, that is a representation of subset. Here if I take this, this is again A. 1, 2, 3 is A. So A is always a subset of A again. Okay. Every set is a subset to itself. And also we can write, we also know the null set, isn't it? Null set is a subset of every set, because null set means no elements. No elements here, you can say null set is a subset of all set. Here now A. So the subsets means a part of the set. And don't get confused with the belongs to. Belongs to, if I write, an element 1 belongs to the set A, whereas the set this is a subset of A. You understood the difference? Elements will belong to the set, whereas a part of the set, subset, is a subset of A. 1 is a subset of A. That means 1 here is B. B is a subset of A. You can write elongated C, or also you can denote it like this. Okay, this is all about sets. Now let's proceed to next, the basic operations of sets. Okay, now we'll talk about the union of two sets. Okay, if I take a set A, 1, 2, 3, 4, and let me take a set B, 5, 6, 7. Okay, these are the two sets A and B. And how do I write the union? Union is represented by U, capital U. So we write A union B is the set of all the elements contained in A as well as in B. Okay, all elements in A as well as in B, we have to list out. That is the union. 1, 2, 3, 4, 5, 6 and 7. This is union. So how do we represent in Venn diagram? If I take this rectangular thing is the universal set mu, and the oval shape, let me write, this is set A and this is set B. Okay. Set A contains 1, 2, 3 and 4. So 1, 2, 3 and 4. Set B is 5, 6, 7. So I will represent like this. And what is the union? Union means all the elements of set A as well as set B. So here you can shade the part. That means all the elements covering A and B is nothing but the union. Now the second operation is intersection. We'll represent intersection with an inverted U. Okay. I'll take an example of 1, 2, 3 and 4. Let me take another set B with 3, 4, 5 and 6. Okay. Now A intersection B means it is a set containing the common elements in the set A and B. The common elements which are repeated in this, both the sets are A intersection B. Here 3 and 4, here 3 and 4. 1 and 2 are not present in B. 5 and 6 are not present in A. So only the elements 3, 4 are common to both the sets. Those common elements, I'll write it in the set of intersection. So you got, children? Union means you have to write all the elements. If there are, if the elements are common, if you see the elements common here, if I have a common element 5, suppose A, The common element twice you should not repeat. Once it's enough. Once you have to write. So that is the union. Whereas here we will list out only the common elements. The rest we should not write. That is intersection. Now the third one is difference of sets. Difference. Difference of sets. You know subtraction. So now we'll see the subtraction in sets. Let the set A equal to, let me take the same set. Okay. Let B equal to 3, 4, 5, 6. Okay. Now A minus B is a set where first the common elements you have to cancel. These are the common elements in both the sets. Those we have to cancel. We are subtracting, we are minusing. Okay. Then what are the elements left over in the first set you have to list out. Do not write the elements in the second set. Okay. This is A minus B. Whereas if you see B minus A, first you have to cancel the common elements. And what is the first set? B. The elements remained in the first set you have to list out. Do not write the elements in the second set. Here the second set is A. So just after cancelling the common elements, write the elements in the first set. This is A minus B and B minus A. And you can clearly see that A minus B is not equal to B minus A. Okay, they are different. Here the diagrammatic representation of intersection. See here. The ovals A and B, the universal set. Now, what are common here? First, I write the set A, 1, 2, 3, 4. Okay. Here, set B, 3, 4, 5, 6. 3 and 4 are common in both. So, I have written in the area which is overlapping, the common part. There, I have written the 3 and 4. Now, the shaded part here is 3 and 4. So, A intersection B is the shaded part. Here A union B is equal to the shaded part. That means here all the elements, here only the portion of the element which is overlapped, or that means the common terms. Okay, these are the basic operations of sets. Okay children, revise the concepts. Today I have told you about the concepts of sets and the basic operations. And next class we will be dealing about the problems in the exercise. Okay, thank you all.